All right, I thought an easy way to do this would be for me to just record part of the textbook, and then I'll just talk you through it as you complete pages 139 to 141. All right, so the first thing is we can look at this objective, and it says, I can write ratios in 3 different ways given a diagram or a description. So just like what we talked about with ratios yesterday, ratios can be written in 3 different ways. They can be written as a fraction, they can be written with the word to, T-O, and they can be written with a colon, the 2 dots. All right, so the first thing we're going to do is we're going to read this Spark Your Learning word problem. It says, Jason and Kiko each take care of several birdhouses. Jace thinks his birdhouses are more popular, but Kiko disagrees. They decide to test their conjectures, or their ideas. Conjectures are just ideas. They both count the number of birds that visit their birdhouses in one afternoon. Jake counts 12 birds that visit his 5 birdhouses, while 15 birds visit Kiko's 6 birdhouses. Whose birdhouses are more popular? So the first thing we're going to do, and I want you to do this in your book as well. The first thing we're going to do is we're going to write in Jace, and he has 12 birds and 5 birdhouses. And then we're going to make a fraction out of it. We're going to make a ratio. So we're going to compare 12 birds to 5 birdhouses. We're going to compare our 12 to 5. Then we're going to make that a mixed number. Right now it's an improper fraction. We're going to make it a mixed number. And then I went ahead and I set it equal to tenths because I actually did that after I finished the problem so I could compare them. But it'll just be a whole lot easier. I'm telling you right now, it's a lot easier if you'll go ahead and set it equal to tenths. So 2 2/5 is equal to 2 4/10 because 5 times 2 is 10 and 2 times 2 is 4. These are actually equivalent ratios. Anytime you talk about fractions, you're really talking about ratios. So they're equivalent ratios. The next thing you're going to want to do is you're going to want to write in Kiko. So Kiko has 15 birds and 6 birdhouses. And again, you're going to make a ratio out of it. So you're going to make an improper fraction. So it's going to be 15 over 6 is equal to 2 3/6, which is the same thing as 2 1/2. And this is why you want to set it equal to tenths, because in order to compare this, you're going to need to have them be equal. So 2 3/6, or you're going to have them be the same denominator. So 2 3/6 is what we got out of the 15/6, because 6 can go, 6 times 2 is 12, and then 15 minus 12 is 3. So you have 3 out of the 6 left over. So then you can reduce that because 3 is half of 6. So now we have 2 1/2. And then the way that I got from 2 1/2 to 2 5/10 is 2 times 5 is 10. So 1 times 5 is 5. So we're going to compare these two. 2 1/2 is greater than 2 2/5. And the reason I know that is because I've already set them equal to tenths. So 2 5/10 is greater than 2 4/10. So in that case, it means that Kiko's birdhouses are more popular. So what I'm going to do is, I forgot to do this earlier, but I'm going to circle Kiko's are more popular. Okay. Turn the page. So I've done a lot of work on these 2 pages, so we're just going to do them one little step at a time. So the first thing you want to do is we're going to read this problem. Maybe, if I can get it to zoom in right. I'm not sure it's there. Okay, wait a second. Let me make it smaller. Okay, hopefully you can see that. Tyree's cat has a litter of black and orange kittens. The tape diagrams shows the number of each color kitten in the litter, with each section representing 1 kitten. What are different ways that Tyree can compare the numbers of kittens? Okay, so we're going to look at this diagram, and it's a tape diagram. So in other words, we can see that there's 4 black kittens and that there are 2 orange kittens. So question A says, how many orange kittens are there? Well, that's easy. We can answer that one. There's 2. And how many black kittens? Well, that's super easy. There's 4. So on the left-hand side over here, I wrote 2 orange plus 4 black is equal to 6 total. Then it says, write a comparison between the number of orange kittens and the number of black kittens, beginning with for each. So in other words, for each orange kitten, there are 2 black kittens. And that should make sense whenever we look at this. For 1, there's 2 here. So for every 1, there's 2 black kittens. So for every 1 orange, there's 2 black. Every 1 orange, there's 2 black. So that's what I wrote for letter A. Letter B, and I underlined what was important here for letter B. It says, how does the number of orange kittens compare to the total number of kittens in the litter? Write the comparison beginning with for every. So that was why I felt like it was important right here to say that the total is 6. Because for every, and we're comparing orange kittens to total kittens. So for every 2 orange kittens, there are 6 total kittens. The next part, letter C. Letter C says, how does the number of black kittens compare with the total number of kittens in the litter? Write the comparison beginning with for every. So the same thing I did, kind of like what I did with the orange one. I did the same thing with the black one, except there's 4 black ones. So for every 4 black kittens, there are 6 total kittens. Then it asks a question about what happens if we change something. So this one, and I'm going to go ahead and tell you the answer is going to be everything doubles. Suppose each section of the tape diagram represents 2 kittens rather than 1 kitten. So now that's twice as much. So everything is actually multiplied by 2. So instead of it being 2 kittens, we have 4 orange kittens. And instead of it being 4 black kittens, we actually have 8 black kittens because everything's being multiplied by 2. So the ratios are still the same though, because everything doubles and even the total doubles. So that means that the ratios still stay the same. So we could say that there are now, instead of there being 2 orange kittens like there were to begin with, each one of these would be 2. So now there's 4 orange kittens, and instead of there being 4, there's 8 black kittens. 4 plus 8 is 12, which is exactly twice the amount of the total. So we still have the same exact ratio. Okay, going on to the next page. And this, maybe we should have done this first, but this is the definition of a ratio. So a ratio is a comparison of 2 quantities by division, either A, and then there's a colon right there, A colon B, A over B like a fraction, or A to B as in the words TO, where B is not equal to 0. So in other words, B is, and you can see that equal sign with a slash in it, is not equal to 0. Okay, so what we're going to do is a ratio can be written in several different ways. A ratio can compare a part to a part to the whole, or the whole to a part. The quantities in each ratio are sometimes called terms. So we're going to compare these terms. 5 is a term and 4 is a term. So 5 to 4, 5 to 4, or 5 to 4. They're all said the exact same way. They're just written differently. So you can see those 3 that are written differently there. All right, first question. It says, Aaron is making a quilt for a craft fair. The quilt is made with 4 different fabric colors as shown in the picture. So here's the picture of it. So you can see that there's 4 different colors. There's blue, there's green, there's red, and there's white. Number 1, complete the tape diagram to model the ratio of the number of blue squares to the number of white squares in the quilt. So I used this tape diagram and I colored in 3 of them are blue and I labeled them. And then I dotted them just to show that I've actually looked at those squares and I know that they're being represented. So that means that those 5 are white. Complete the statements to describe the ratio of blue squares to white squares in part A. So blue to white, and notice that it says blue to white. You couldn't put 5 to 3 because that would be white to blue. You have to look very carefully here, and it says blue squares to white squares. So you're going to do 3 to 5, and I went ahead and labeled my B and my W just so I didn't get mixed up. 3 to 5 and 3 to 5. They're all said the exact same way, just written differently. So for every 3 blue squares, there are 5 white squares. Part C, it says, write a part to whole or whole to part comparison about the quilt using symbols and using ratio language, such as for each, for every, or the word per. So any of those 3 phrases are talking about ratio language. I'm going to go ahead and move this out of the way for a second because I'm going to tell you how I wrote it, and then we can talk about it a little bit more. Well, I can talk about it a little bit more. I guess you can listen a little bit more. Okay. So there are 4 red squares. So I can count that there are 4. 1, 2, 3, 4. And then we needed to compare part to whole or whole to part. So we're going to compare part. The 4 red squares are a part of the quilt. The whole amount is 15. I counted up these and I found out that there were 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 total squares. So for the red squares, there's 4 of them, and there's a total of 15. So I'm going to compare part to whole. So for every 15 total, there are 4 red squares, or there are 4 red squares for every 15 total. Part D is probably the trickiest one on here. It says for every small green square, there are 2 large green squares. Does this mean that 1 out of every 2 green squares is small? Why or why not? No. Because when we talk about a small green square or we talk about the large green squares, when we add those up, there's 3 total. So 1, 2, 3. So for every 3 total green squares, 1 of them is small. Not 1 out of 2, it's 1 out of 3 total. So because 1 plus 2 is 3, 1 out of every 3 is small. Small, I have the small, big, and the total written there. If you need to pause this video, you can. That way you can write in what you need to. Finally, we're going to work on check understanding. I have to be honest about this. I messed up on this one at first, so there's going to be some whiteout. I'm not really sure why I thought that dogs had 2 legs for a second, but I did. But dogs have 4 legs. Okay, describe in ratio language and with symbols the relationship between the number of tails and the number of legs on a dog. I had 1 to 2. 1 tail to 2 legs, but it's really 4. 1 tail to 4 legs, 1 to 4, 1 to 4, 1 to 4. And finally, number 2. A recipe that makes 8 cups of limeade uses 2 cups of lime juice. Describe the related ratio 2 to 8 using ratio language. Okay, so that's the first thing we're going to have to do. So we're going to say for every 2 cups of lime juice, you can make 8 cups of limeade. So that's how we're using ratio language. We're using 4 and comparing those 2. And finally, it says, does the ratio involve only parts or does it involve a part and a whole? So it's a part and a whole because we're talking about the lime juice make up part of the whole entire 8 cups of limeade, rather. Okay, your homework is, and that you have until the beginning of class on Thursday to get this done. So today and tomorrow you're working on this. You're working on numbers 3 through 8 on page 142. You're going to leave this one in your book. We'll go over it on Thursday. And then you're working on pages 143 and 144. And you're going to tear this out and write your name on it. Make sure you write your name on it. And your name goes right here. So you can tear it out now if you want to, or just leave it in your book so that way you don't lose it. Okay, thank you. And you can go ahead and get started.